Hello everyone, welcome to today's presentation on trip distribution using the first method, that is growth factor method. Hmm. So here in the growth factor method, in the earlier presentation as we have discussed, there are four methods. So out of that I'll be discussing the first method, that is constant or uniform factor method. So before that, this growth factor, as we know, it is applicable for small towns, or where the growth of the particular zone or the study area is not affected by the external factors. And here the trip making pattern remains the same will remains the same, and but the volume of the trips will increase according to the growth of the different zones. That is, it may be with respect to the trips which are the zones which are attracting the trips, or it may be the zones which are generating the trips. The volume will change, but the pattern of growth remains the same, right? So here we'll discuss the first one, that is uniform or constant factor method. Constant growth factor or uniform growth factor method. So here this the assumption made in a uniform growth factor method is the growth of the zone remains the constant, or the study area will have an equal effect on all the trips in the area. Means uh, this is one of the oldest or earliest method which was adopted in trip distribution, based on the assumption that the growth which is expected to take place in the survey area or the study area is equal effect on all the trips. For example, zone 1, 2, 3 are there. So whatever the number of trips which are going to generate, or it may be attracted, it has an equal effect with respect to zone 1, 2 and 3. It is uniformly growing, uniform or a constant growth rate of all the zones. It's not that only zone 3 is randomly growing. hmm. It is uniform growth of all the zones, but the number of trips may vary. It's not trips are not constant, but the growth of that particular zone is constant. Okay, so the relation between the present and the future trips is given. So this is future trip between I and J is given as the present number of trips between zone I and J into the constant factor, hmm, that is which is calculated from the present and the future number of trips. This will see in the when we solve the problem how it is calculated, this constant. Okay, so to calculate the future, this is capital Tij is the future number of trips between zone I and J, and small tij is present number of trips, hmm, between zone I and J. Okay, and capital E is the constant factor derived by dividing the future number of trips divided by the present number of trips. Hmm. So this is a simple formula. Capital Tij is equal to small tij into the growth factor constant capital E. Okay. So here we'll see the example. Here I have considered three zones: zone 1, zone 2, zone 3. So these zones, this is origin and this is destination. Whatever red marks are, red colored numbers are there, that is given in the question, that they will mention between between the zones 1 there are 60 number of trips, between zone 1 to 2 that is 100 number of trips are being attracted. This is nothing but the trips attracted, and this is number of trips generated or originated, right? Trips generation or trips originated from this zone. So from zone 1 to 2, 100 number of trips are there. Zone 1 to 3, 200 number of trips are there. Like this, they will be giving in the that we need to put in the matrix. So this is trip generation and this is trip attraction. So how we need to put? So for example, if they are mentioned from zone uh, 3 to 1, then attracted number of trips are 200. So from zone, first of all, you need to mark like this total number of zones. How many number of zones are there? 1, 2, and 3. 1, 2, and 3. Okay. Between the zones, number of trips generated and trips attracted are 60. So right here 60. Between zone 1 origin and trips attracted towards the zone 2 is 100, right here 100. Zone 1 generated and zone 3 attracted number of trips are 200. So with respect to generation and attraction, they will be giving the numbers. Those things you put up in the matrix as it is. Okay. And next step is, that is to calculate the total number of trips which are generated from zone 1. So total number of trips which are generated from zone 1, here it is 100 plus 200 plus 100 plus 60, 360 number of trips are being generated. Similarly here from zone 2, 300, 420 number of trips are being generated. Similarly here it is 520 number of trips are generated. Next is sum of all the trips. Sum of all the trips is 1300. Next, capital TIJ is, this is nothing but the future number of trips which they have given in the question. Future number of trips attracted towards the zone 1 is 360. Future number of trips attracted towards the zone 2 is 1260. Future number of trips attracted towards zone 3 is 3120. Like this, they will be giving in the question, right? So that sum is 4740. So how to calculate the factor E? Factor E we can calculate, it is future trips divided by the present trips will give us, that is growth factor E, 3.646. Okay, so this is a growth factor we have calculated from these trips. This he has given in the question, this we have calculated from the matrix, right? So total number of trips which are being attracted in the future divided by the total number of trips in the present will give us the growth factor. That growth factor we need to multiply here. So how will you multiply this calculation? So T11, this you need to do it. T11 is trips originated and destinated between these two trips. How to calculate 219? This is present trip is how much? The formula is capital Tij is equal to small tij into constant factor E. Capital Tij what I want? Capital T11. Capital T11 I want. So small t11 is how much? 60. Small t11 is 60. Here you have no t11 is 60 into how much? What is the growth factor? E is 3.646, right? So how much you'll get? You'll get somewhere around 219, right? Similarly, we need to calculate for T12. T12 is how much? T12 is the number of trips between 1 and 2 is 100. 100 into growth factor is 3.646. It is nothing but 364.6. That I'll make it as 5. right? 365. Here we have written. Similarly, we need to calculate T13 is equal to 200. 200 into 3.646. So like this, we'll calculate 729. So like this, we need to calculate for T21. T21 is how much? 100 into 3.646. It is 360. Like this, we need to calculate the second matrix. This is first iteration. First iteration of growth factor, right? So first iteration, what we are going to get? The future predicted traffic with respect to this given growth factor. This is a given growth factor and this is a predicted, right? So again, the sum of all these from zone 1 will give the future trips. That sum will calculate here. Sum of total trips attracted towards zone 1, 2, 3. And the future what he has predicted is given in the question. That also you'll write in the another column. So here the growth factor is 4740 divided by 4740, that is 1. So we need to calculate the number of iteration till we get growth factor as 1. Growth factor as 1. So here first iteration how much we got? 3.646. Second iteration itself we have got e is equal to 1. So like this we can solve the problems with respect to constant or uniform growth factor method. It is very simple method. Just first of all you need to put the values in the matrix, then calculate the sum of all those things, sum of future trips what he has given, future trips divided by the present trip which will give us the growth factor value, that growth factor value into the values which are there in the present. That is P11 is equal to 16 to 3.646. Like this you will get the first value. Similarly 100 into 3.646, 100 into 200, sorry, 200 into 3.646, 300 into 3.646. Like that you will get the matrix. From matrix again calculate the sum of the trips attracted towards 1, 2, 3. Well, if you get the same values, that is the last part of uniform growth factor method. Okay, thank you very much.